buongiorno. That's about all the Italian I know. Actually, according to Duolingo, I have about 200 words, so I'm working on it. So thank you all for the super warm Italian welcome, and thanks for coming out to my talk. I'm going to have to beg your forgiveness in advance because I've been a really, really bad Italian tourist already, and this is only my second day here. I got here yesterday, and the first thing I did is I couldn't pay my toll on the autostrada, so number one. And then number two, I didn't order right. I went to a British pub for dinner. That didn't quite settle well. And then third, I know this is a Ruby conference, but this is my favorite shirt. I always give my talks in this yellow shirt, and you'll have to forgive me, it's a JavaScript shirt. So I hope that you'll forgive me in advance for all of these heretical maneuvers at an Italian Ruby conference. But this talk will be in Ruby. I promise you, there is not a line of JavaScript in it. So this talk is by me. That was a very strange way to introduce the first slide, but I'm Jonathan Martin. I am from the USA, not from Italy. And I like Twitter, by the way. I'm at Nibbler, for those of you who like to tweet. That's NYBBLR. And I work at a place called Big Nerd Ranch. Big Nerd Ranch is in Georgia in the USA. We are a consultancy. We write books, we write apps, and we teach intensive mobile developer boot camps out in the middle of nowhere, usually in the woods, so you can get away from all the distractions. So all that said, come say hi to me after the talk, and I'll be happy to take all your tips on how to navigate the Italian roadways at no charge, because I have no more euros after all the autostrada. I'll keep using this. There we go. Thank you. All right, so a while ago, actually, it's been quite a while ago, about a year ago, I was working on a talk that was going to be about code loading in multi-threaded environments, namely sidekick jobs, or for those of you who have used Rescue, similar situation. Well, at the time, Ruby's auto-loading system was not thread safe, and Rails had a really nasty habit of crashing really randomly in our sidekick workers, usually with a circular dependency exception. You all have probably run into that on random occasions, and typically it was probably when you were running your test suite and you eventually found the one line that made it, and it made no sense why it caused that error. So today's talk was going to be about replicating that issue with multi-threading and code loading. And that was all super awesome until Ruby 2 fixed that issue. So later versions of the Ruby 2.x series fixed this by making auto-loading thread safe. And then active support came along and fixed its own issues with the addition of thread locks. So a great part of the more humorous part of my talk is no longer relevant. This is unfortunate. So that means that with the time we have, we actually get to talk about the useful part of this talk, which is covering all of Ruby's code loading mechanisms and the best practices around those mechanisms. So probably a little bit more dry compared to some of the really great talks we've seen before, but hopefully lots of information to take home. So newcomers and seasoned Rubyists alike often have a very shallow understanding of how Ruby's magical code loading just works out of the box, especially if they come from a Rails background, because in Rails you don't normally have to think about code loading, especially if you just do Rails, generate, app. It just kind of works out of the box. You just start typing code here, and it shows up there. You don't even have to think about it. That's nice because it keeps the barrier to entry really low. But as soon as this new developer or someone from another language background bangs their toe on something, especially during a high-stress deployment, they break things and then they go cry about it. And usually when they've had a good cry, they then fly to Twitter to publicize that stubbed toe, and they do it with all the right hashtags too. This is what's especially annoying. And then they go on and they criticize Ruby's code loading and auto-loading mechanisms. And then they also like to go on about the confusing differences between require and load and require dependency and require relative. Which one of these am I supposed to use? And then they take it a step further usually. They post pictures which graphically depict those feelings. This was my favorite reaction. It showed up in the feed with hashtags Ruby and autoload. So I thought that was a little bit strange. Now, when they stop getting retweets and favorites, likes, They like to give a talk about those grievances and call into question if Mats really is nice. And this really bothered me until about a year ago. So those reactions were all kind of fishy until I started hitting this issue. So a year ago, I had become one of those doubters. So I took to the Twitter waves while my production sidekick workers were completely up in flames. And I went and composed my 105-character tweet. It had the correct hashtags and everything to be a viral anti-Ruby campaign. At the end of the day, I decided not to hit the publish button, so you will not find this tweet on the internet. So instead, I just realized that, I haven't actually taken the time to learn how Ruby's code loading works. And so maybe my grief is due to laziness and that low barrier of entry, and not because Matt is mean. So in order to preserve Matt's reputation as an awesome guy, we're going to revisit Ruby's various code loading mechanisms in depth, and then we'll be able to make our own educated opinion about best practices. And then you can go tweet at Matt. He hates auto-loading too, so you'd be in the right camp. So first off, we're going to break down the built-in eval, load, and require methods. Now some of you, especially if you watch Ruby Tapas, have probably seen a similar breakdown, so I'm not going to go into depth on this. So huge thanks, by the way, to Avdi Graham, who runs that particular podcast, for his really good systematic breakdown. Breakdown. I'm having a breakdown. He broke down the methods very nicely, so I could present this. So we'll be working on a recipe app. It's called Cookery. It's going to be written in Ruby, and eventually we'll tack on some Rails stuff. It's a very simple project. We'll have one file that's our entry point called main.rb, and that'll be our entry point for loading the entirety of the application. So that's where we'll be spending most of our time. And we'll also be nesting our main app code under the Cookery module, where we have a recipe and ingredient class. I chose these words because these were the only words I knew in Italian, so if we have QA later, I'll know how to say these words. So before we even get into files out, we're just going to start in a plain old REPL session. We're just using IRB here. And Ruby is an interpreted scripting language, which means that we should be able to fire up a REPL and start coding away with literally no difference between that and writing a file and running it with Ruby commands. So they should be very, very similar. So first off, if we're in a REPL and we execute the toS method in a REPL with no receiver, in other words, we don't see self dot or some object dot, it's implicitly calling self.toS. This is something we're used to in Ruby. But if you take it a step further, we're doing the same for puts. It's self.puts and then self.toS. Well, that method comes from the object instance. So whenever we run our code in a REPL, all of our code gets called on whatever the value of self is. Well, self is just initialized to an object instance. Now all objects inherit from the kernel class, and the kernel class has a private method, puts. It has another method too called eval. So eval, unsurprisingly, can take a string of Ruby code and evaluate it in the current context, just as though we had typed in the toS manually. But eval can do a whole lot more than open us up to security vulnerabilities. We can pass in as a second argument this binding object. Now this binding object is not the same as passing in another object to use as the context. A binding object wraps around the values of what is self, what is that implicit receiver, and also what local variables can I access. And so this allows us to execute code in a different context altogether. So for example, if we wanted to execute our little puts toS inside the cookery class, or not cookery, here we have just cook, and we made the get binding method leak out what that binding is, because that binding is normally private, then we can execute that code inside there, and instead of printing out main like it was before, it actually prints out this nice, lovely string. Now this isn't terribly useful. We don't want to be typing all of our code in an eval, so normally we'd move it out into a separate file. So we're going to leave the REPL for a while and start putting our code in files. So here we've created a cookery : recipe class, and it just prints out a message at the very top when the file is first loaded. That's just going to be useful for debugging purposes. Now notice the file path. I've put file paths for all of these at the bottom of the file, so if you're trying to get a handle on where we are in the project, just look at the bottom. So in our main.rb file, we're going to load that class. The way we'll load it is we'll take the _ file variable and we'll expand that. We'll try to find out what directory this file is located in, and then tack on a relative path to that recipe, which is going to be cookery/recipe.rb. Now eval just takes in a string of Ruby code, so we're going to call file.read to get those contents. We'll pass in binding. Notice we're just calling binding. We're not getting it from somewhere else. This is because kernel also has a binding method, which just returns the binding that we're currently in. This is the default whenever eval is called. And then for the third argument, we'll pass in the relative path, and then fourth argument, we'll pass in the line number this file starts on, which, as far as I know, is pretty much always 1. So we'll just put 1 there. Now the only useful part about this is stack traces. Whenever our code blows up and that method happened to belong to the recipe class, we now know where to look. And our logs will tell us this error occurred in cookery recipe. And there's nothing else to be done there. If we run the code like we expect, notice that whenever we run these, it's printing out that nice message. This is going to be really useful later on when we're trying to debug whether a file was loaded or not. Now, it's kind of irritating having to do all of that from scratch. Why do we have to even do eval? Well, we don't. We have the load method, which is also a kernel method. So this is kernel.load. Kernel.load takes in an absolute file path, at least for now, and then it loads that file. It executes it in the current binding. Now, it's kind of irritating to have to build that path up from scratch, so it'd be kind of nicer if we didn't have to. If only we could tell Ruby about the directories where our code is executed and then just give it a name of a file, similar to how Bash works. In Bash shell, we maintain a load path. That load path is an array of all directories where we would find executable binaries. Ruby is no different. We can add any directory of Ruby files to this load path global variable and then just call the kernel.load method with cookery/recipe.rp. Now, this is a really huge improvement already over eval. But there's a lot of different ways that we could require this same file. So, for example, we might have several different entry points. Maybe we not only have main.rb, maybe we also have a test file, and that test file needs to be run. Or maybe we have several test files. Maybe we have several tests that in the end need to load the recipe class. Well, that means that potentially in the same REPL session, we might load the same file of code multiple times. Now, that doesn't seem so awful, but that can cause issues a lot of times. Notably, as we'll see later, constant redefinition warnings. So in general in Ruby, we only want to load the source code once, not twice or 3 times, as might happen if you were running a test suite. So the way we can get around this then is we need to keep track of whenever we load in a file to memory. So that way, next time we try to load that file, we know, nope, it's already loaded, don't need to do it again. Well, in C, the way we get around this is we have a declaration. So C gets around this problem by allowing you to load the file more than once. Or in some cases, you can change it up so that it guards against it. Well, in Ruby, we're going to take the former approach. We have a method called kernel.require, and require solves this issue by keeping a list of all Ruby files that have already been loaded. Now, notice the name of the global variable is kind of strange. It's loaded features. It's not loaded files, it's not loaded Ruby files, it's loaded features. Now, require, as we would expect, loads code into memory. Now, we have to set the load path using the unfortunately named unshift method. The unshift just prepends an entry to the top of the load path because Ruby will search from top to bottom. And when we require it, we can look at the loaded features list and it will now contain the absolute path to the file we loaded. Now, it's called loaded features because you can actually load more than Ruby files into memory. You can load up .so files, static objects. You can load in, if you're on Windows, dynamically linked libraries, DLLs. You can load all of those in so long as they work well with Ruby's virtual machine system. So instead of calling it loaded Ruby files, we call it loaded features because it's going to actually contain a lot of the Ruby core library, which is compiled C code. Now, one other point to note is that loaded features does not store the file path that you pass in to require. Instead, it resolves that path you pass in to the absolute file path, and then you can require the same file in 2 different ways, but it only loads once in the end, which is really useful because from different files. You might require the same file a little bit differently, but you really want to make sure that that file only loads once. So with that little bit of prep work, we're now ready to move on to some more contentious parts of Ruby. Just as a side note, we are from now on going to be using this chunk of code. What we're going to do is from now on, we're always going to assume that this is in the main.rb file, and we'll just cover it this once, which is we're going to make sure we load up active support. Active support is a library that's part of Rails, but it can be used in your other projects, and it tacks on a lot of core extensions. One of the things it does is it makes the auto-loading a little bit nicer, and it also adds the auto-loading mechanism we're all used to in Rails, which is where you just pass in directories of where code is located. The default Ruby auto-load mechanism does not work that way. So that provides that for us, which is pretty useful. The second line, we're just getting what directory main.rb is in, and then we're adding that to the load path. So that way we can require cookery/recipe or cookery/ingredient. And then just at the very bottom, that fourth line, we're going to print out what the last loaded feature was. And this is just going to be useful for debugging because later on we'll be looking at that loaded features array to see what has last been loaded. So now we're ready to move on already to the most contentious code loading mechanism in all of Ruby world, which is auto loading. And if you ask Mats or you do any Googling on Mats plus auto load, you'll find a lot of very heretical documentation by himself saying how much he hates autoload, which is rather unfortunate. Autoload is a brilliant piece of work, but it was really nasty until Ruby 2 when we got multi-threading support. So active support autoloading lets you specify directories defining classes, or more generically, defining constants. And then you can go on to access any of those constants or classes without an explicit require statement. So here, for example, at the very top of the file, we're going to add the root directory, which is going to be the parent directory of main.rb, to our autoload paths. And then we'll be able to directly reference cookery : recipe. Notice there's no require statement, there's no load statement, none of that. All we have to do is reference the constant and autoloading kicks in for us. Now, it does print out that message right after we reference cookery recipe. It says that it loaded the class. So our little puts s did its job. Now, autoloading very strongly relies on conventions, and if you break any one of the conventions ever so slightly, you will end up with the craziest undebuggable issues in your production sidekick workers, which is not a great way to be spending your time, especially since Ruby's supposed to make things, it's supposed to make developers happy. So if we want to be happy developers, if we need to follow these conventions to a T. So imagine replacing your double colons with a /, and that's probably you'll avoid 90% of all autoloading issues. Now, when a constant has not yet been loaded and you make reference of it like we do here, active support is just going to look through all of the autoload paths and append that relative path to it, in this case by taking the class and substituting double colons for a /. And it'll do that in every directory in autoload paths. So it sounds a lot like kernel.require in that we have a load path of sorts, only it's in auto load paths. Now, by default, autoloading uses the kernel.load method. So that very top line I've commented out, but this is the default behavior. The default loading mechanism for autoloading is to use kernel.load, not kernel.require. So that means that if later on we decide to do any manual requires in our code, we're going to have to change the mechanism. Because if we don't, we'll have the issue we had on this last slide, which is if we make reference, or if we use autoloading to load cookery recipe and then do a manual require at the bottom, it's going to load that file twice. Notice it prints that message again, so that means that it's evaluating that file a second time. And this is because it's using the load mechanism. The load mechanism doesn't look at the loaded features global variable. It just loads it in all the time. So to get around that issue, we need to change the mechanism to require. And as soon as we do that, the next time we do a manual require, it just doesn't do anything. We have this eerie silence of no output. So it should really seem like the require mechanism is ideal for preventing these sorts of multiple loads. But why does active support dependencies default to the load mechanism? It seems like it should default to the require mechanism if it's going to cause issues like this. So we'll revisit that a little bit later. Now there's another autoloading mechanism, and it's part of Ruby core, and this is actually the part of autoloading that Matt laments. If you go look at any of the tickets he's submitted or any of his tweets on the subject, they're all referring to Ruby's core autoload feature. And this is also another method on kernel, kernel.autoload. Kernel.autoload is inherited by all modules and allows you to specify a constant that can be accessed in this class. For example, cookery : recipe. Recipe is a class, but it's also a constant. So with autoload, we can specify what constants should be autoloaded if someone tries to make reference of them. Active support has its own extensions, however, that just make it a little bit nicer. With Ruby's built-in autoload method, you also have to pass in a file path. Well, active support just relies on conventions for this sort of thing, and so it makes it a little bit tighter. You don't have to use any file paths or anything. So this one is really common in Ruby gems. Now, it's falling out of favor now that Matt has very liberally taken to Twitter and decried it. So it's going to probably be deprecated in Ruby 3, so no more autoload, which makes me kind of sad. This does work nicely in some gems, but it can be a pain. So to make use of this, we have our cookery module. Notice this is the cookery.rb file, and we're going to extend that module with the active support extensions and call autoload. So now, back in main.rb, all we have to do is we have to require that entry point. In this case, the cookery module is our gateway to the recipe. So if we call cookery : recipe, the cookery module is already loaded into memory. So auto-loading looks at cookery and sees that we can access recipe on it, and it knows where to load that file. So we get that nice message. Now notice if we look at the loaded features, it's in there. So this means that auto-loading, at least the one built into Ruby core, always uses require. Now this is an important distinction because the autoload paths defaults to load, whereas this mechanism, which is used in a lot of Ruby gems, always uses require. If you look through the source code, there's no way to swap it out really, unless you do some monkey patching. So that's a little bit strange, but it might make a little more sense later on. So conventions are going to be really important, and if we break any of these conventions, we'll get one of the next 3 issues that we'll take a look at. So all these conventions let autoload do its magic. So if we break those conventions, we're going to get some very strange exceptions. So we're going to revisit cookery/recipe.rb. This file should look very similar except for one minor change. We no longer have that module cookery wrapped around it. And this is a fun error because it happens in about 50% of the code bases I come across. Someone has just left off one of the module wrappings. So if we go back to main.rb and we're going to set the mechanism to require, if we try to load cookery : recipe, we'll notice that it does evaluate that file. It does find the file and it loads it. However, it gives us that wonderful unable to autoload constant cookery : recipe. So that just means that it took the conventions. In this case, we said that it should define cookery : recipe. So it converts that to cookery/recipe. So it found the right path, but it finds out at the end of all of that, there is no such thing as cookery : recipe. Now, you won't get this issue in an example this simple. Where it normally comes up is you have multiple ways to load the exact same file, but those multiple ways go through slightly different paths. And so very often you'll get an error that only comes up in your test suite, hopefully, or in Sidekick, not so great, or in your production website, which is especially bad. Now, the good news about this is that auto-loading is smart and it throws an exception, which is not so awesome for production, but it does keep us from quietly loading a null, I can't even say it, JavaScript. It prevents us from loading a nil constant. Because otherwise, if we ran this, cookery : recipe, this would probably be nil or something like that. But thankfully, this throws an exception and crashes everything. I promise I wasn't working on JavaScript right before this. Now, autoload paths normally look something a little bit more like this, where we actually have two different directories that we're loading on there. So in this case, we have root/cookery and root. Now, notice that if you think about it, one of these directories contains the files of the other. In this case, root contains all the files that are in root/cookery. This is a problem because now we have two ways that we can access the exact same classes. So in this example, we're going to leave our cookery/recipe file the same as it was, which was messed up at the time. It didn't have that module cookery. So if we try to reference recipe without that cookery : this works perfectly. It looks in all the directories we've specified, and it sees that within root/cookery, there is a recipe.rb file. And it tries to load it, and voila, we have a recipe class. That works great. It even gets put, in this case, in the loaded features. But then we try to access it with cookery : recipe. Now notice that it doesn't print out a message this time. It says loaded : recipe class the first time we access recipe, but then the second time when we try to access it with cookery : recipe, it does not print out that loaded message. So this is good. This means that kernel.require did its job, preventing the same file from being loaded twice. But at the end of the day, we still have an exception, and our application crashes and goes up in flames. So that's not so awesome. And unfortunately, this is a really easy issue to get, especially in Rails applications. So we don't want to run into that issue. The one that most of you probably see on an almost day-to-day basis, unless that's just me and I write really awful code, which is totally an option. If you mix and match autoload with require, there's often going to be a showdown in production that triggers the infamous constant redefined warning. So we're going to roll back our changes to cookery/recipe.rb, and we're going to add a constant, conveniently called constant, which is just a string that we've frozen. Not incredibly useful, but it'll illustrate the point. So we're going to set up autoloading again. This time we're going back to the load mechanism, just for illustration. We're going to add the root directory to the autoload path, and then we'll try to load cookery : recipe. Seems to work fine. If we print out the loaded features, however, it's still looking at the last thing that we actually required, which was active support. That's not so awful, actually, because autoload is smart. It knows when we've already loaded the same constant before. The problem is require doesn't. Require just looks at loaded features and sees that we haven't actually loaded this file before, and so it tries to load it. So it evaluates it a second time, and we get already initialized constant. So the nice thing about this is that it's a warning. The bad thing about this is it's a warning. So if you run your test suite, you probably won't see this issue. If you run in production, you probably will not see it either, but it'll be an issue. So that's not great. That means there's something wrong with our autoloading setup. Now, the easy way to get around it is we just set that active support dependency mechanism to require again, and everything's fixed. So it really seems like active support mechanism, setting it to load, isn't really a whole lot of use. So require seems like the way to go, right? And then probably my favorite one, which was the inspiration for this talk, which is circular dependencies. And it should have a side note that says, especially in important sidekick jobs. So it's pretty easy to trigger this infamous error. It's almost impossible to debug and trace. So I'm going to have to generalize here very, very significantly. It took me about 6 months to come up with even this replication, is my warning. So we're going to go back to our cookery/recipe class, and the only thing we're going to do is we're going to change constant from that very strange string to ingredient, which is going to be another class. So let's go look at cookery/ingredient. At the very top, we're going to print out that nice load message, and then we're going to have constant refer back to recipe. Just to make things a little bit more fun, I've also got a require statement in here, and this is not made up. I have a particular code base in mind where this especially blew up, but I've seen this in just about every other Rails application. It's normally hiding many, many directories down where most people will never touch that bit of code. So we'll move on. And in main.rb, we'll just try to load cookery : recipe. And the load message pretty much says it all. It first tries to load the recipe, and then it tries to auto-load ingredient, because when it was evaluating that file, it also evaluated the class. Well, we had a constant. That's got to be evaluated. So it looked up recipe. Well, that looked up ingredient. Well, ingredient requires recipe. Well, we're still using kernel.load because autoloading under the hood is using kernel.load. So that means recipe was never actually loaded in the eyes of require. So require is going to go back and try to load it. And now we get autoload stepping in to save the day. It says circular dependency detected while autoloading. Again, autoloading actually does this in our favor. It keeps us from going into what would otherwise be an infinite loop. So that's kind of a nice thing, but what isn't so nice about this is we might want circular dependencies. Now, it could very easily be argued circular dependencies are not a great thing, and I 100% agree. The sad thing is you do it all the time. It's a really good example. If you have a very modular plugin system, you might want to have an array that refers to all the plugins that have been loaded. Or you want to have an array that keeps track of all of a class's subclasses. Well, you can do that, but it's probably going to cause issues. So the way we can avoid this seems to be require again. Require keeps coming to our rescue. And if we set it like that, it loads up recipe, loads up ingredient, and then doesn't say anything else. So it really just seems like we should just always set that mechanism to require. Or we could have gone back and removed that explicit require statement. Now that should have been the trivial solution, but unfortunately this issue is in just about every other Rails app that you'll look at, especially if it's a fairly large application, because at some point different developers have been on that project, and some of them prefer an explicit require, some of them prefer auto-loading, and when you mix and match the two, everything falls apart. So, but this was one way to fix it, and then we can go back to the kernel.load mechanism, and everything just works again. So now we're going to shift a little bit from the plain old Ruby world to a more Rails-esque environment. And in fact, this is going to be the point at which Cookery is suddenly a Rails application that I've not written code for. So this is just going to be a Rails application. Now under the hood, Rails does all of its code loading through active support's autoload paths, which is unfortunate naming because if you go look at your configuration file, there is an option called autoload paths. It seems like a very conveniently named method, and it's an array, and you give it a path to autoload code from. The unfortunate thing is this is actually not going directly to active support's autoload paths method. And furthermore, it knows nothing about a production environment. So this seems to work. The problem is when you go into production, this will not work. Because in production, autoload paths are not actually what you want. You want the eager load paths. So in development, anytime you make reference to a particular class, it will be loaded. If you tried to do that in production, it would load the same file 3 or 4 or 5 or 10 times, however many requests happen to come through on your website. So you might get the same bit of code loaded about 2,000 times. That's not really a great way to make Ruby known as a very performant language. So instead, we have to use the unfortunately named eager load paths method. Now, this is unfortunately named for 2 reasons. Number 1, it's very poorly documented. Number 2, that's actually not all it does. Eager load paths not only tells Rails what files it should automatically load as soon as it starts up in production, it also tells it in development what files to autoload. So it does 2 tasks at once. So a lot of times, people will actually put both of these in there. They'll have an autoload path and an eager load path, which just means it takes twice as long to find the same file. So just use eager load paths. That's a really easy way to prevent lots of issues, especially in your sidekick jobs. That was a hard year. Now this is another sneaky slip up, and it's especially popular with former Java design architects who are used to packages. They very carefully use the eager load paths because they went and read the correct blog post on how to do this sort of thing. And then they add directories that are subsets of another load path. So in this case, they add both app/models. Okay, most people don't make that mistake. They usually make the second one, which is app/models/queries. Pretty much insert anything of app/models/x. And you'll find that in about every other Rails code base. So this works actually. This won't completely blow up on us unless we happen to have more than one developer on the project and that second developer goes and tries to make use of one of our queries, and they forget the query : namespace. Well, it works. They'll try to load that query object by its name without the query : part, but then you go run this in production, and depending on which job runs first, it will load that class, and then if you load it a different way the second time in another job or in production, it'll just crash. Not so great. So, case in point, do not load or do not append nested directories to autoload, or in this case, eager load paths. Make sure that they're always completely separate directories and they're not nested in each other. Now, furthermore, in Rails at least, everything under /app is already added to autoload paths. So if you want to make your own directory called app/queries, do it. Put all your query objects under there, and then you won't have to use query : But I personally like the query : so that's not something I tend to do a lot. But you can do that, and it'll work out of the box. So in general, if you see someone setting autoload paths, freak out. If you see someone setting eager load paths, just eye it very, very carefully and submit a pull request to get that fixed. And now we finally get to our last tip, which also pertains to Rails. So Ruby might be somewhat performant, but Rails is really, really, really slow. It takes like 5 to 10 seconds sometimes just to load up a test suite, just to load that environment. We don't want to inflict that on all of our nicely written unit tests, which already mock out third-party dependencies. At least they should. So to make this test isolation easier, we want to write an isolated spec helper that sets up just the minimum autoload environment. Now the point of this is a lot of people, when they go to an isolated test environment, in other words, they're testing lots of their code without the Rails environment, they have to go back to require statements. And this will cause a lot of the issues that we've just worked so hard to get around and that Rails fixes for us. So the other way we can fix it is we can just set up an autoloading environment that's almost exactly like Rails's. So what we can do is we can check, first off, we need to set the Rails env variable to test, and then we're going to see if Rails has been loaded or not. And if it hasn't been loaded, we're going to load up active support. So the other thing this does is this gives us access to blank, present, a lot of those convenience methods we tend to use. And it also allows us to set up the autoload paths. In this case, we're going to initialize it to Rails defaults, which is just any directory under app is autoloadable. And then finally, at the very bottom, we want to have a basic RSpec configuration. This is where you're going to put options that apply to all of your tests. Not those that require Rails, just all the ones that apply to all of those. And then we're going to create a Rails-specific helper, which only loads the Rails environment, and then it loads our isolated spec helper, and then at the very bottom, we'll set up any sort of Rails-specific RSpec configurations, like use transaction figures. So then in our test, if we want to write an isolated spec, we can just require that spec helper and then start testing away. We don't have to manually require any of the code we want. We just autoload it. So this means that many of your tests can actually run as though they were in a Rails environment, but without having to use require statements or anything. So this makes it a lot easier to move from a test suite that's taking 30 minutes to run to one that takes about 30 seconds. As a case in point, we have 3 code bases specifically where we did this sort of approach. We had test suites that were taking around 5 to 10 minutes, and after moving to a more isolated approach, we were able to get it down to around 30 seconds, which made it a lot easier for people to run the test suite when they were developing. So for the most part, that was just a lot of information. So now I want to get to the second part and the last part of this talk, which is giving you all a little propaganda to take home with you. So here's some takeaways. Now, just as a caveat, all of these issues are grossly simplified examples, which you probably won't see exactly like them, unless you really do make constants that are called constant. So these examples were all taken from major code bases, which are otherwise top quality. If you look at their code coverage, the quality of the tests, spotless. But all of that to say, you are not immune to these issues. So these issues often disguise themselves, and they often take new developers prey, especially people who have just hopped onto a project. So just keep an eye out. So here's some general propaganda. Many of you might have very different opinions, and I'd love personally to hear your opinions, because I'd really like to make sure that I actually have a good understanding of what's going on here. So the first is we saw a lot of setting dependencies.mechanism, and this is an anti-pattern. It's an anti-pattern because it's actually a cop-out for a poor loading setup. It usually means that you're mixing and matching require with auto-loading, which causes other problems too. You're also short-circuiting the power of autoload. Autoload is very performant. It only loads the files that you need when you need them. So if you're having to set the mechanism to require, which in Rails you do this by setting the no reload flag, well, you're probably going to cause subtler problems down the road. But here's the biggest takeaway. It kills live reload in development. So if you're a day-to-day Rails developer and you're developing and you're running your server and you keep typing your code, you keep making new classes, if you use require anywhere in there, you're going to short circuit the live reload mechanism. So this is why active supports dependency mechanism is set to load by default. It allows the Rails to do auto-loading on the fly for you, and it allows it to reload your code anytime you make changes to it. So if you follow those conventions and you make sure everything's auto-load friendly, you get reload, or you get live reload in Rails for free. And you don't have to keep killing the server, starting it back up, kill the server, start it back up. And related, don't mix autoload and require. Now, there are some very subtle exceptions to this rule, especially when it comes to test suites. But in general, your production code, whatever gets shipped to production, should not use the require statement. You shouldn't even have to use it for gems because Rails is already going to be loading those for in general with bundler.require. But if you do have to manually load a gem, that's one exception to that rule. But in general, try to avoid that. Try to commit to one or the other of these two mechanisms. And then a lot of people try to make their code immune to constant redefinition warnings with this bit of code. They do an or equals assignment. And this seems great. It makes your code immutable or immune to multiple loads of the same code base. The problem is you're ignoring the root problem. And number two, if you change this constant while you're running the server, if it tries to live reload that same file, that constant will not get updated. And that's liable to cause frustration down the road. In your Rails code, you're more likely to see autoload paths, but if you're writing a gem today, you're probably going to be using the autoload method or using active support autoload. The caveat I give you is that this is probably going away in Ruby 3 because Mats hates it, and therefore we should hate it. However, it's very nice, and I've used this in quite a few gems to great success, and a lot of the larger projects out there, Simple Form for example, some of the authorization libraries, really like to use this. Hopefully we'll get something better to use. When possible, try to use your isolated spec helper instead of the Rails helper. This will make your test suite much faster, and if you just want to keep rerunning that same test over and over again to do TDD, you can do it, and it'll take maybe half a second to run as opposed to 3 minutes to load up the Rails environment. 3 minutes, that might be overkill. And this is probably my favorite. I see this, a lot of people who are a little bit more autoload savvy, they use required dependency. In general, just don't use it. It's basically an autoload friendly version of require, and there are only 3 recommended scenarios where you use it, one of them being single table inheritance. Most code bases don't use single table inheritance, so if you just do a grep in your code base or ACK, whatever search tool you prefer, just look for the keyword require and start on a pull request. And all these examples are online, so if you want to try to compare some of these with your own code base and look for it, but probably the easiest way to get started on fixing these sorts of issues is just do a grep in your code base for the word require. And that'll get you to about 95% of the offenders.